Hey guys, so today we're going to do the Unit 5 test review. So we're going to go through the questions that are on the study guide. So number 1 is just wanting you to prove that you understand exponents and what they should be. So you're telling if they're true or false. If they're false, you are to correct this statement on the right side of the equation. So this one, you have 4 to the power of 3 is equal to 4 plus 4 plus 4. Well, it absolutely is not. It should be 4 times 4 times 4. For B, 1/4 times 1/4 is equivalent to 1/4 squared, so that one is true. C, you have x times x times x times x times x, says that it is equal to 5x. It is not. It is equal to x to the power of 5. 3 squared says it's equal to 2 times 2 times 2. It is false. It should just be 3 times 3. And then 9 squared is equal to 3 to the power of 4. That is true. And 1 over b times 1 over b times 1 over b times 1 over b is equal to 1 over b to the 4th power. That one is also true. So hopefully you got those right. Number 2, it's asking you to evaluate the expression. Anytime you're asked to evaluate an expression for a given value, you just plug it into the equation. So we have 4 times 3 to the power of x instead of x. I'm going to put 2. And then you just solve it from there. 3 squared is 9, so I have 4 times 9. 4 times 9 is 36. So that is your answer. Number 3, which expression is equivalent to 5 to the power of 0? Anything to the power of 0 is always 1. So 5 to the power of 0 is 1. All right. For this one, it's just wanting you to prove that you understand the rules of exponents when you're multiplying, dividing, or raising something to a power. So any of those rules of exponents we've gone over. So for A, 2 to the power of 9 times 2, well, anytime you have exponents with the same base, you just add the exponent. So it's the same as 2 to the power of 9 plus 1, which is equal to 2 to the power of 10. So that one is true. Anytime you're dividing and the bases are the same, it's the same as subtracting the exponent. So it's 2 to the power of 11 minus 1, which is also 2 to the power of 10. So that is true. 10 squared is not even remotely close. 10 times 2, not close. And 2 to the power of 5 raised to the power of 2, you're going to multiply them. So it's going to be 2 to the power of 5 times 2, which is 2 to the power of 10. So that one is also true. All right. Which expression is equivalent to 5 to the negative second? So you need to make sure you understand negative exponents. When we talked about these in context of problems, it also referred to a time before the initial value. So it doesn't make your answer negative, but it means you take the reciprocal of it. So 5 to the negative second power, we can rewrite that and make it 5 squared if we put it under 1. So 1 over 5 squared, which simplifies to 1 over 25. So anytime you have a negative exponent, you can just rewrite it as 1 over that problem. So whatever that is, it becomes positive. All right, so now we have a table with several points that tells you it's on a line, so you know it's a straight line. It wants you to write the equation of the line defined by these points. So for you to do this, you need to remember that you need an equation in y equals mx plus b. So you need to find out what your slope and your y-intercept are. If you're really good at finding patterns, you can kind of look at the values of x and see what you do to get them to be y. Or you can use the slope-intercept form and find the slope by looking at 2 points. And so if you're good at finding patterns, that's great. If not, I would suggest trying to calculate the slope. So it's y2 minus y1 over x2 minus x1. And so this is something you've been doing since 8th grade. Hopefully you remember how to do it. So we have our x and our y points. So make this your x1 and this your x2, y2, y1. So we're going to do 16 minus 10 over 5 minus 3. That simplifies to 6 over 2. 6 divided by 2 is 3. So I know the slope is 3. So I'm going to have y equals 3x. From there, I know if I plug in a value of x, I should be able to get the output here. So if I plug in a 3 for x, I should be able to get 10. So 3 times 3 is 9. What do I do to get 10? Or if I plug in 5, 5 times 3 is 15. What do I do to get 16? Well, both of those are 1 away, so I just add 1. And that also works if you plug in -2. So 3 times -2 is -6, plus 1 is -5. 3 times -1 is -3, plus 1 is -2. So there's your equation there. All right, number 7. A child ate 30 grams of cereal for breakfast. Her brother ate 40% more. How much did her brother eat? So there are several ways you could have done this. You could find 40% of 30, so 30 times 0.4, because you have to turn that percent into a decimal. And then you add back the original 30 grams, and you get 42. Or you could have done 30 times 1.4 and gotten 42, or 30 times 1 plus 0.4, that also equals 42. So any of those ways would work to help you get that percent, because you have the original amount and you're just adding 40% more. So anytime you're adding a percent more, it's 1 plus the percent when you're putting it in multiplication. Part B is a pair of shoes that normally cost $30 and they're reduced by 25%. So instead of adding that percent to 1, we would take it away. So it would be 30 times 1 minus 25%, or 30 times 0.75%. Or it could be 30 minus 30 times 0.25. And all of those give you 2250. So knowing the multiple ways to do this will help you answer number 8. So let's look at number 8. It wants you to select all the expressions that mean 10% more than x. So 10 plus x does not work. That is not 10% more. Adding a tenth to x does not work. Taking a tenth of x and adding x, that does work. That's the same thing we did when we added 40% more. Adding a tenth of x plus 10 does not work because x is not 10. 1.1x does work, and x times 1 plus 1/10 also works. Because those are all equivalent expressions, they're just rewritten in a different way. All right, number 9 wants you to interpret some key features of graphs and be able to interpret the information that you're given. So what you needed to pay attention to here was that it is hours after 8 a.m. So it wants to know all of the true statements. So A, we're looking for G of 0 equals 50. So I'm going to go to 0 on the graph, and looky there, it is at 50. So that's a true statement. Then B says G of 12 represents the temperature at noon. Okay, so here's what we have to pay attention to. Hours after 8 a.m. is on the x-axis. 0 means that is 8 a.m. right here. Okay, so if that's 8 a.m., then I have 9, 10, 11, 12. So G of 4 would be noon. G of 12 would be, so if this is noon, 1, 2, 3, 4, 5, 6, 7, 8. G of 12 would be 8 p.m. Then part C, the maximum temperature shown on the graph happens at 3 p.m. So if we're looking at 3 p.m., I know 4 is noon. So then I have 1, 2, 3 p.m. is 7 right here. And that is the highest temperature on the graph. Then I look at D. So I have G of 11 is less than G of 8. So go to 11 and it's a little above 60. And go to 8 and it is about 75. So G of 11 is less than G of 8. Part E, the temperature increased about 10 degrees Fahrenheit between 8 a.m. and 1 p.m. So 8 a.m. we know is at 0 on the graph, so that's about 50. And then we need to look at 1 p.m. So 4 was noon, so 5 is going to be 1 p.m. And that's a little above 70. So that is a change of about 20, not 10. So it's about 20 degrees, not 10. So your answers here would only be A, C, and D. So you need to make sure that you can interpret the information that's provided by the graph. Oops. All right, so number 10, we have a game show and it records multiple rounds. Each round has 3 times as many points as the previous round. So we know that there's 3 times as many points. Which equation shows the number of points available, P, in round N of the game show? So we need an equation for this. We know it's tripling, so we know it's going to be exponential. So we can go ahead and count out A and C. And then I know it's tripling, so that's my growth factor. And I can see in the table that my initial value is 25. And so I know that an equation in exponential form should be y equals the initial value times the growth factor raised to the power of x. So your growth factor always has the exponent on it because that's how many, it's telling you how many times you're multiplying that factor by itself. And so in part B, it says my initial value is 3. It is not. And it says the growth factor is 25. So these two values are switched. So it is not B. And here I have an initial value of 25. And my growth factor is 3. So that one is true. So hopefully you all picked option B. All right, number 11, these equations represent the number of bacteria in 4 dishes as a function of time and days. Which equation represents the population with the greatest growth factor? So we're looking for the largest growth factor. So that tells us that we're looking for the number that is being raised to a power. So it's either 5/6, 1/50th, 5/2, or 3. And so out of all of those numbers, the largest value is 3. If it were to ask you what the largest initial value is, we would look at the number that is by itself. So 1,000, 800, 600, and 400. So our largest initial value would have been option A. All right, number 12 wants you to pick the correct graph. If a computer loses 1/3 of its value every year. So if it's losing value, we can go ahead and mark off the ones that are increasing. It's not going to increase in value over time because it's losing value. And we know that it's losing 1/3 of its value. It's not losing the same amount every time. It's losing 1/3 of what it had the previous year. So we know that it's not going to be linear because those values are not going to be the same. So hopefully you picked option C. Number 13. An online music service is collecting 1,500 songs. It expects it to triple every year. So I have 1,500 and I know it's tripling each year. So we have to write an equation to represent the relationship where X is the time in years and Y is the number of songs available. So to write our equation, we go back to the same thing we did before. You need the initial value and you need the growth factor. So 1,500 songs is your initial value. And tripling is your growth factor. So that makes it really easy to write the equation because it's Y equals the initial value times the growth factor to the power of X. So 1,500 times 3 to the power of X. As long as you have the initial value and the growth factor, you can write the equation. Jada saw a music video that her favorite artist recently posted online. The equation shown represents the number of views of the video T days after Jada saw it. So we're asked to find V of -2. So V of -2, I'm just going to plug it into the equation. So V of -2 equals 320 times 4 to the power of -2. So when you solve that, you can just type it in your calculator, and V of -2 equals 20. What does V of -2 represent in this situation? Well, it tells us that the video only had 20 views 2 days before Jada saw it. So we can say the video had 20 views 2 days before Jada saw the video. Okay, so the video had 20 views 2 days before Jada saw the video. All right, number 15 is just showing that you can evaluate an expression and put it in a graph and a table. So all of these values, we have the equation y equals 8 times 2 to the power of x. It gives you the x values, so you just plug them into the equation and solve for y. So 8 times 2 to the negative third, 8 times 2 to the negative second, 8 times 2 to the negative first. All the way down. Okay, so 8 times 2 to the negative third, or you can start with the easiest one. And so you can type this in your calculator and get it pretty straightforward, or you can start with the easiest one. Anything to the power of 0 is 1, and we know that. So 2 to the power of 0 is 1. 1 times 8 is 8. And since I know it's doubling, because my growth factor is 2, if I multiply 8 times 2, I get 16. If I multiply that by 2, I get 32. If I multiply that by 2, I get 64. And negatives don't make my answers negative. It means I'm going backwards in time. So if I'm not doubling, I'm cutting it in half. So if I take 8 and cut it in half, I get 4. If I cut that in half, I get 2. And then I get 1. So there are my values, and it's the same thing you would get if you typed it in your calculator. And so now you just take those values and you plot them on the graph. You have negative 3, 1, negative 2, 2, negative 1, 4, 0, 8, 1, 16, 2, 32, 3, 64. All right, so hopefully you can plot those ordered pairs on there and plug those values into the table. All right, the last question. The milligrams of aspirin in a person's body is given by the equation where T is the number of hours since the patient took the medicine. So how much aspirin will be in the patient's body after 2 hours? So we know we're looking at 2 hours. We just have to plug 2 into the equation. So A of 2 equals 500 times 3/4 to the power of 2. And when you solve that, A of 2 equals 281.25. In the equation, what does the 500 tell us? Well, if you're looking at where it is in the equation, it tells us it's the initial value, and in context of this problem, it means that the person started out with 500 milligrams of aspirin in their body. In the equation, what does the 3/4 tell you? 3/4 we know is our growth factor based on where it is. So the growth factor of 3/4 tells us that the patient is losing 1/4 of the aspirin every hour, or that 3/4 of the aspirin remains every hour. So it's the growth factor, and it tells us 3/4 of the aspirin remains each hour. Okay. And then we have to graph these values for values of t between 0 and 4. So you can just make a simple XY table. And we need 0, 1, 2, 3, and 4. And so we already found the values of 0 and 2 because we did them up above. So the initial value was 500. So 0 is 500 and 2 is 281.25. If you find 1, you're just going to plug that in. So 500 times 3/4 to the power of 1, and you'll get 375. Do it for 3, so 500 times 3/4 to the power of 3, and you get 210.94. And do the same thing for 4, you get 158.20. And then you just plot these points on the graph. So we have 0, 500, 1 and 375, 2 and 281, 3 and 210, and 4 and 158. And so hopefully you were able to calculate those values and find them. So hopefully this helps you with your test. These are not the same questions that will be on your test, but the concepts are the same, and hopefully it helps you. Let me know if you have any questions. Y'all have a great day.